The heights of dogs at the city animal shelter are distributed normally with a mean of 25.4 inches and a standard deviation of 4.8 inches. Part A says sketch the normal curve and divide the area under the curve into sections that are 1, 2, and 3 standard deviations from the mean. So the mean always goes in the middle, that's 25.4. From here I'm going to add 4.8 when to fill in the blanks to the right. So this is going to be 30.2, 35, and 39.8. And then I'm going to subtract 4.8 to get my numbers going to the left. So this is 20.6, 15.8, and 11. The next thing I'm going to do is write down my percentages. So 0.15%, 2.35%, 13.5%, 34%, and then it's the same percentages on the other side. So we have now done part A. So the answer for part A is just this curve. Part B says, if there are 73 dogs, what percent of the dogs would you expect to be less than 20.6 inches tall? So the first thing I'm going to do is find 20.6, which is right here. And I'm trying to figure out what percent of the dogs would be less than 20.6 inches tall. So I want all of the intervals going to the left of 20.6. So what I'm going to do is take all the percentages that are to the left of 20.6 and add them together. So 0.15 plus 2.35 plus 13.5. And when you add these together, you end up with exactly 16%. Now, a lot of times when it gives you the total number of, in this case it's dogs in the shelter, a lot of times what they're going to do is ask you to find how many dogs that translates into. So if that were the case, which it is going to be moving forward, what you would do is take the total number of dogs, which is 73, and you would multiply it by 16%. So you would take 73, and you'd actually have to multiply it by 0.16 because you'd have to translate 16% into a decimal. And when you figure this out, you get about 11.68, but since we're talking about dogs, we'd have to round it to the nearest whole number. So we'd be talking about approximately 12 dogs. The heights of adult American males are approximately normally distributed with mean 69.5 and standard deviation 2.5 inches. Part A goes straight into asking us questions that require us to have our normal curve labeled. So let's do that first. So 69.5 is the mean, so that goes in the middle, and then we're going to add 2.5 going to the right. So my first standard deviation is 72, then 74.5, then 77. And then going to the left, I'm going to be subtracting 2.5. So that gives me 67, 64.5, and 62. Next, I'm going to label all my percentages. Okay, so now I'm ready to get started. First question, what percent of adult American males are taller than 6 feet? So 6 feet, first of all, this is kind of tricky. If you notice that this gives us information in feet, and the mean and all of our numbers that are along the axis, the bottom axis of our normal curve, are in inches. So the first thing I want to do is figure out how many inches 6 feet translates into. So 6 feet, if I multiply that by 12, 6 times 12 is 72. So this question is really asking what percent of adult American males are taller than 72 inches. So now I can see 72 is one of my numbers here. and I want to know what percent are taller. So I'm going to start at 72, and I'm going to add up all the percentages that are to the right of 72. So that's 13.5, 2.35, and 0.15. So 13.5 plus 2.35 plus 0.15, that's a grand total of 16%. Next question. In a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? So now this is the type of question where we need to take the percent that we just found, which is right here, and we're going to multiply that percent as a decimal times 2,000. So I'm going to take 2,000 and I'm going to multiply it by 0.16, and this turns out to be exactly 320. So what this means is that if I had a group of 2,000 males, 320 of them would be 6 feet or taller. If 95% of the students at school are between 1.1 meter and 1.7 meters tall, find the mean and standard deviation. So I'm going to use option 1. So step number 1, we're going to find the mean, or the middle of our normal curve. So we're going to do this by finding the middle of the 2 points. So the middle of the 2 points you would find by adding them and dividing by 2. So this ends up being 2.8 divided by 2, which gives you a total of 1.4. So now I know that the middle of my normal curve is at 1.4. Step 2, it says, what percent of data did they give you? And you'll notice that in the problem, it says if 95% of the students. So 95% should automatically make you think that it's 2 standard deviations away from the mean. So I'm going to write that it's 2 standard deviations. And I know that because it told us that 95% of the students fall within this range. Okay, so now we're looking at step 3. So step 3, it tells us to subtract one of your points and the mean. And actually, I'm going to go back and I'm going to put these points down, 1.1 and 1.7. And the reason I put them where I did is because this is 2 standard deviations to the left and to the right. So that's why, since it was 95%, I knew that was 2 standard deviations. That's why I wrote the 1.1 and 1.7 where I did. All right, back to step 3. We're going to subtract one of our points and the mean. Now, I would do this so that it's you're getting a positive answer. So what I'm going to do is take 1.7 and I'm going to subtract the mean, which is 1.4. You could have done 1.1 minus 1.4, but then you would be getting a negative number. You could do 1.4 minus 1.1. I just always tend to pick the biggest number and subtract the mean. That way I'm not going to have to worry about any negative numbers. Okay, so this gives me 0.3. And then step 4 says to divide that answer by the number of standard deviations we got in step 2. So that means I'm going to take 0.3 and I'm going to divide it by 2, and my final answer is 0.15. So that's my standard deviation. And then what's really nice about these problems is that you can go back and double check your work. So if you start with 1.1 and you add 0.15, that's going to give you 1.25. And now if you add 0.15 again, you can double check that it does give you 1.4. And then if you add 0.15 again, you would get 1.55. And then you can double check again that it gets you to 1.7. So you'll know right away if you got the wrong answer, because when you try adding them, your numbers will not match. We're going to go through this example a little bit faster. I'm not going to write out all the steps because I think it actually looks like a more complicated problem than it really is. So the first thing I'm going to do is take a look at the numbers it gave me, and I'm going to pay close attention to the percentage. 68% should automatically make you think that we're talking about one standard deviation away from the mean. So I don't know what the mean is, but I know that 6.5 and 8.5 are going to be one standard deviation away. So that means they're going to be right next to the mean on either side. So the first thing I'm going to do is take those two numbers and add them together. 6.5 plus 8.5, and then I'm going to divide them by 2, and this is going to tell me the mean. So that's always your first step. So mean, you take the 2 points that it gave you, divide by 2, and I end up with 7.5. So that is the mean. Now for the standard deviation, you may be able to just look at this and tell what it is. But you won't always be able to do that. And maybe you just want to know for sure that you're doing things correctly. So to find the standard deviation, I like to take the largest number that I have, which is 8.5, subtract the mean, which is 7.5, and we're going to divide it by the number of standard deviations, which is 1. So I'm going to take this total and divide it by 1, which essentially is doing nothing. So 8.5 minus 7.5 is 1, divided by 1 is 1. And if you look over here, if I just looked between 6.5 and 7.5, what's the difference? That is the standard deviation. So I know that this is 1, this is 1. So again, you might have been able to see it, but this is how you could do it mathematically.